Hello. In today's lesson, it's the second part of proving triangles are congruent. So basically what you're going to be doing today is kind of laying out the formal proofs that we kind of in a way looked at yesterday. So yesterday we explored the different properties. So I'm just going to write them up here. We explored side, 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 angle, side angle, 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 side, and then the HL property. Okay, so these are the properties that we looked at and we kind of saw how they worked. We found two of them do not work. So we found AAA does not work, and then the swear word one does not work. It only works if you have a 90-degree angle. That's the only time it works. So if it's a non-90-degree angle. So basically in today's proof, all of them are going to work. We're not going to have any nots. You won't see that today. So I should not see these two properties listed on your paper, okay? And so when we look at our proofs, notice the last line of the proof is always to prove the triangles are congruent. So we know we can fill that in. In this last step, so in this prove statement, you only have these options from above. So these are the only options that you can fill into this last line. You just need to figure out which one it is. So if you look at the given, notice how the given gives you two sides. So we have two sides. Well, we really only have two properties that have two S's in them. These other properties, well, I guess this one kind of has two S's because HL, but I can tell you from my diagram, there's no 90 degrees, so I know it's not going to be HL. So I can tell you right now, and I'm just going to kind of lightly write this, it's either going to be this property or it's going to be this one because we only have two options, okay? So just to save myself some time, you guys know that this is the given. You know the word given goes here. So we either need another side to get this property, because we have two sides. We either need a third side or we need an angle. So when I look at this diagram, I really don't have a way to justify the angles being equal. But I do know that they share this piece. So if we were to pull the triangles apart, they both would have this LM in them. And because it's the same side, we can say that it's equal to itself. And the property we would use is reflexive. That's the property you use when you're equal to yourself. So the reflexive property. And then notice now we have side, side, side. Side, side, side. So that would be the property we would list here. Okay? So that's your goal. Your goal is to try to show the triangles are congruent by one of the properties that we explored in yesterday's lesson. So if we turn to page 12, and really if you look at page 12 and page 13, there's 5 proofs. Really, I mean, there's not a lot for me to quote on teach you. It's just kind of helping you know what to use. So again, if you notice, we're trying to prove the triangles are congruent. So in this last spot right here, I only have those options, side, 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 side angle, side, that sort of thing. So what property is going to go here? So let's take a look at our given. First of all, we know the triangles are going to be congruent. So let's take a look at the given. We're given that it's parallel, so I'm just going to kind of write this quickly so this video isn't super long. And then we're given that we have a side. So BC is congruent to AD. And it's already marked in our picture. So we have this side. So we know we have one side. It's just a matter of, do we have angles or do we have other sides? Whoops, I said sides and I was about to write it. So given. Now, really, these two steps can be interchangeable. It doesn't really matter which one you write first. And in class, I'm going to ask for a volunteer, but since I'm all by myself right now, then I'm going to go with reflexive. I'm going to go with this piece right here, okay? So that piece is going to be equal to itself. Now, that might be difficult for us to write at the time, but let me just write down AC is congruent, and we know this is reflexive. Now here's the piece. If you're looking at the top triangle, that's this one, okay? So this is the top triangle, this is the bottom. If you look at the letters, if you do A first, excuse me, if you do A first, if you look over here, do you see how C goes first? So then this should match with C. Notice C from the top triangle needs to match with A from the bottom. Now notice these are the same piece, but what's happened here is this triangle, instead of being reflected down, it's been rotated. So this is actually a rotation, okay? So that's why we need to switch the letters. Now, if you forgot to do this on the test, I probably would not take points off. But again, as a teacher, I'm trying to be as accurate as possible, so you would want to reverse the letters. Okay, so I have two sides now. So I have two sides. I either need a third side or I need an angle. Now, there really is no way for me to justify this side is equal to this side. Like, I don't have a property. But what I do have is I do have parallel. Parallel, we learned in chapter 3. So from chapter 3, we learned stuff about angles. So again, if we were in class, I would be asking you. So notice if this is parallel, then this angle and this angle right here are alternate interior. So we have that theorem that says if our lines are parallel, alternate interior angles are congruent. So we have that theorem. So now we need to say that these are congruent. Now just be careful, you cannot just say angle C, because if you do, I'm not going to know if it's the top or bottom. So the top angle up here, I'm going to call that BCA. And then the bottom angle, I'm going to call that DAC. So now I know I have an angle, but here's the problem. Does the angle go like on the outside or does it go in between? Well, let me first tell you, it cannot go on the outside because remember, the swear word only works if you have a 90 degree, which we don't have. So I know that it has to go in the middle, but I also just want you to look at this. So if I was to draw potentially this bottom triangle, so let's say I draw the bottom triangle here. You're going to have the bottom piece was equal. We just found this to be an alternate interior, and we said this is reflexive. Do you see how the angle is physically between the two A's? So that's how we know what property to use. So we have 3 proofs left in the lesson. What I want you to do is pause the video and I want you to try it on your own and then watch the video to see if you got it right. And then you'll pause and then try it, okay? So go ahead and pause it here. All right, hopefully you've paused it. If not, hurry up and do that, okay? I've got my given. I've got my triangles are congruent. Again, I'm just trying to save myself some time here. I'm going to go ahead and mark this. So this one right here says BCA, which is this angle, is congruent to DCA, which is here, okay? So notice I know I have one angle. Now, this, you need to remember how to read this, and I believe it was from chapter 1, the word bisect. So it says AC bisects this angle. This is the angle right here that got bisected. Well, doesn't the word bisect mean to split in half? So we know that this left is equal to this right. Kind of almost looks like 2 eyes, but these 2 angles are the ones that are equal. So I'm going to say the left angle, so this is the one on the left, is congruent to the one on the right. And basically, that's just from the word. So definition of, if you want to say angle bisector, or if you just want to say bisect, that's fine. So notice now I have 2 angles. I do not want a third angle because that's not a good property. So we know we need a side. And hopefully you're kind of noticing when the triangles touch, this piece right here is what we call reflexive. So we know we're going to have a reflexive piece. Now, here's the key, is when you write your letters, AC, do we switch them? And the question is, basically, has your triangle been reflected or has it been rotated? If the triangle was rotated, as it was up here, so it was like a rotation, we switch the letters. If the triangle has been reflected or folded, we do not. And notice this one would be folded, because that way the angles match each other. So this one we do not need to switch the letters. Now we know we have a side. Now we do have to be careful because both of these properties are actually good. So we could use either one depending on the layout. So again, if I were to draw this right side, and I'm only drawing the right side because I'm right-handed, so it just is easier for me to draw. I've got this little dot up here. We just found this reflexive and we were given this angle. So if you notice the setup, we have angle, side, angle. Do you see how the side is physically between them? So that's how I know which property to use. Okay, so there's never a guess on which property. You always look at your diagram and then you can decide. All right, so we've got 2 more proofs here. So go ahead and pause the video and try it on your own. You've got to be trying these on your own because I'm not going to be with you on the test, okay? All right, hopefully you paused it. If not, quick do so. This is definitely a long given, so if you just want to kind of go like this, I totally get it. We've got our triangles congruent. Now, yes, you should fill in the letters. I'm just, again, trying to save this video not to be super long. Okay, so it tells me that B is the midpoint. So if this is the midpoint, then don't I know that the left side is equal to the right side? So I'm going to start out with CD is congruent. Now be careful. C has got the 90. Oh, that's a B, sorry. My little dot went over top of it. It was hard for me to see what that letter was. So CB, C is 90, which is going to go to D. So C has to go to D. And then this is a B. Again, if you look at this, you can tell that this triangle is probably getting reflected, like it's getting folded. So these two are the ones that match up. Okay, so that's definition of midpoint, because they told me it was a midpoint. So they told me that up here. Now they're also telling me this. So they're telling me that AB is equal to EB. So they're giving me that. So if you notice, I've been given 2 sides. Now they're also telling me this is right. Now here's the tricky piece. If you want me to give you hints, you're going to have to go with what I would use. In order for you to say that these are equal to each other, so angle C is equal to angle D, you cannot say definition of a right angle. Definition of a right angle would tell you they're 90. Then you would have to add an extra line and do substitution. So if you want to go straight from this to here, you have to use a property, I believe it was from chapter 3, and it's called the right angle congruence theorem. But if you want to use definition of right, then you're going to have to add an extra step to do substitution. So it wouldn't be too much, but you would have to add an extra line. Okay, I do have an angle. And if you notice, again, if I draw this right triangle, this right side, I guess, because again, I'm right-handed, so it's just easier and my hand doesn't block the camera as much. This was marked, and now 90. If you look at this, this is technically the swear word. Do you see how the angle does not fall between them? So this is the swear word. So it's really this one. So if you wrote this on your test, I would give it to you. But the book wants you to use HL for hypotenuse leg. Okay, remember, the swear word works if you have a 90-degree angle. All right, you got 1 more to go, so pause the video here and give it a try. Notice you've got right angles again, so you kind of already have an idea about that theorem. So go ahead and pause it here and try it. All right, hopefully you paused it, and again, I'm just going to kind of go like this to save myself some time. And I know that I'm trying to get my triangles congruent, and I know I'm trying to go for one of my theorems. So let's just start with the given. They're telling me that these are parallel. So if what we found in a previous example was if they're parallel, then we have alternate interior angles. Now, we could have corresponding. The problem is they're not inside our triangle. We don't want to use same side because those aren't going to be equal. And remember, to show triangles are congruent, we want things equal. We don't want them to be 180. We want them equal. So I think alternate interior angles are going to be our best bet. So I just need to name this kind of lower left. So this is the lower left. And then I need to name this one. Now notice I started with F because it was 90. So I'm going to start with K. So KGH. And it's really important that you kind of work and practice on how to get your, write your angles. Now just so I remember, because I'm getting old and I forget, I just showed I have one angle. So I've just used up this part of my given. Now I want to use this part of my given. So I've got that these are both right. So if I remember that property, I can say they're congruent by the right angle congruence theorem. Now again, if you want to use definition, you're going to have to add on an extra step, okay? All right, I've got two angles. I do not want a third angle because AAA, again, is not a property we want to use. So we need a side. We need one. And hopefully you're noticing again by now, every time these triangles touch, you have reflexive. So we know we're going to use this reflexive piece. So I'm going to start with the top triangle, and I'm going to call this HG. Whatever you put on the left, now you have to make sure your right side matches. So if you look at these, would you say that the triangles have been folded, or would you say it's been rotated? And I would say it's been rotated. So if it's been rotated, notice how I did, like if you look at the top triangle, this is HG, and if you look at the bottom triangle, see how this is HG? Basically what would happen, is when I rotate this triangle, this corner would go to this corner. So I need to reverse my letters. And again, if you don't reverse them, I'm not going to mark you down, but I want to demonstrate good habits because that is the correct way. Now, here's the key you got to really watch for. You're going to want to say HL because your eyes are seeing this 90. But if you're going to use HL, then you have to be given essentially two sides with a 90. I agree we have a 90. I agree we have a side, but you don't have another side. So if you look at this, and again, I'm just going to use this bottom one so that way, again, you can kind of, my hand doesn't block the picture as much. So those are like the same triangle. Here, let me draw it maybe a little bit better. There's the same triangle. Okay, so we have this 90, we have this alternate, and we have the hypotenuse. If you look at that, isn't that angle, angle, side, or side, angle, angle? It is not the swear word. And that's HL, is the swear word. So what we have here is we have angle, angle, side. Now remember, it doesn't matter the order. So if you want to call this side angle, angle, that's perfectly fine as well. It's just because it doesn't spell anything interesting or unique, the book typically writes it alphabetical. Okay? So that concludes this last lesson, which was all about proofs.